In this problem, we're doing some more U substitution to find an indefinite integral, this time with inverse trig functions. And if you haven't worked with those before, we've got a handy chart up here, or even if you have worked with them before, you probably don't have all these memorized. A handy chart of the derivatives of the common inverse trigonometric functions. Remember, with U substitution in integration, what we're always looking for is some part of this that's the derivative of the other part. And that other part we're going to call our U. And we can take our hint here from the fact that we have the inverse trig function of arc cosine. If we look up on our chart here, the derivative of the arc cosine is negative 1 over the square root of 1 minus x squared. So I think this is going to work out if we call U, that whole bit on the top, 1 plus the arc cosine of z. Now, that is going to make du equal to, if we, well, du with respect to z, if we take the derivative of 1, that just goes away, it's a constant, and then we have our arc cosine. So that's negative 1 over 1 minus z squared. Okay. So you can see that's pretty similar to what's going on here, and I'm going to arrange this so it's just defined in terms of du. So I'm going to multiply it by dz on both sides. So we got du equals negative 1 over the square root of 1 minus z squared dz. And then I'm going to factor out that negative 1 because we don't have a negative sign here. So I don't want du to be a negative. So I'm going to divide by negative 1. So I get negative du equals a positive 1 over the square root of 1 minus z squared dz. Now, it might be a little hard to see, but I think we're ready to actually substitute all of this back in and get it in a form where we can actually take the integral. So let me show you how this works. We define this part up here as u. So I've got my integral sign, I've got a big square root, and I've got u. And then I've got, well, I've got all of this that is du, right? So 1 over, so we'll think of this as a 1, and then we've got 1 minus z squared, and then we've got dz. All of those things, let me put that in a different color. All of this is this. So I'm going to substitute that with du. So this is going to be square root of u du. Now that is in a form, oh, wait a second, it was a negative du, So then I'm going to factor out the negative 1, bring it out front, so negative 1 times the square root of u du. And I'm actually going to think about that as u to the 1/2 du. And we've got our negative sign out here. Okay, so now we can integrate this. We can take the antiderivative. So I'm going to raise the power by 1. That gives me 3/2. And then I've got my negative 1 out here. I've got, so u to the 3/2. And then we're going to multiply by the reciprocal, so 2/3. So what I'm going to have is a negative 2/3 u to the 3/2. And at this point, I can substitute back in my u, which was 1 plus the arc cosine of z. So this is going to be negative 2/3 times 1 plus the arc cosine of z to the 3/2 plus big C, because this is an indefinite integral. So that's a little bit of work using substitution to find integrals of trigonometric or inverse trigonometric functions.